right? So that is what a procedure. Procedure, the same thing you say functions or you say method. In Java, you call them as methods. Again, there's no real difference. This is just the naming convention. You say methods in Java and you say functions, procedures in C, C++, and all those kind of languages. Okay. So the difference between a procedural language and an object-oriented programming language is that procedural language extensively depends on procedures. So now what do I mean by extensively depends on procedural language? If you see, if just pick out, let me just pick out this program. I'm actually writing data structures in C. So this is actually C, C++. So these are nothing but data structures programs. No, is it? No, it's recording. I actually started the recording. So this, as you can see, this is actually a data structures, a stack queue program in C, C++, C. All you can see is a bunch of functions. I'll scroll through the entire 100, 200 lines of this code. All you can see is just function. This is a function. This is a function. Function, function, function. These are all functions. That's it. That is what a procedural language has. So how a procedural language works is one function talks to another function, or one procedure talks to another procedure. So it's tightly coupled, right? So if you were to remove one function from the program, if I were to remove what, for example, if I were to remove the create stack method, then this entire program will break down, because it kind of entirely depends on this thing, right? I have to make changes altogether. If I'm changing something in this thing, then I have to change in the rest of the functions, because somehow all these methods or all these functions are dependent on this one function. So there is no, kind of modularity in procedural languages. But whereas in object-oriented programming language, you don't see functions of this, a program of this kind. You will see something called as objects. Everything. This is the beginning class, so I don't use the word object a lot. But as we keep on progressing in the Java, you keep hearing the word object a lot. Whenever I usually keep referring, this object, you have to pass this object to that method, and this method will accept this object. You have to declare an object. You have to make an object. So you can just tell that object-oriented language or an OOP language is extensively dependent on objects. Okay, so that is one major difference between a procedural language and an OOP language. As you can see, the second difference, interaction between functions rather than real objects, right? But whereas interaction between real objects you can see in an OOP language. Okay, concentration on the process rather than data. For example, C leads to complexity of code. It may not be reusable, maintenance cost is high. So disadvantages that come with the procedural language. Now, what is an object-oriented programming? Okay, again, object-oriented programming is you actually use your program extensively depends on objects. You create objects, you use objects, everything that you want to do, you first make an object out of it, and then you solve a problem. That is how it works. I'll let you know what an object is in a minute, but I'll just finish the slide. Yes, each object has its data, and it's easy to understand the code. And some of the advantages of using an OOP programming language is these two: usability and extendability and modularity. Yeah, I can give you the definitions of these three words right now, but there's no point. You can always Google it. But the thing is, I want you guys to realize what these three words are. As we keep on progressing to write code in Java, you'll actually realize that our programs, even those programs are as simple as calculating something or printing something, but you'll actually realize that those programs will actually reflect modularity, reusability, and extendability. I'm sure you'll realize those things. Okay. So again, modularity is something. For example, you have written an application, right? You have written an application. So one of my friends is developing in another application. So the thing is, functionality is kind of similar to some extent. So instead of him starting from the scratch, he can always take one part of my application and just directly plug into his application, right? So if an application is module friendly, like it has a couple of modules, and then you can just keep on switching modules. Have you heard of this phone Project Ara on Google? They actually shut down. It's a wonderful project. You've never heard of this thing, Project Ara? Well, the Project Ara was, we all have the smartphones, right? So the problem with these is, what's the problem with a smartphone? I mean, buying an $800 smartphone, it gets old real quick. You have iPhone 7 and then iPhone 8 coming up in a couple of months, right? So these phones get old real quick. So what the Google came up with an idea was, instead of buying an entire phone as a package, and then once, for example, only if you have a phone and then and then iPhone 8 comes up, and the only difference between them is that I'm just giving you a hypothetical case. So you have an iPhone 7 and then iPhone 8 is coming up, and the only difference between those two phones is that iPhone 8 has a better camera. So only for that better camera, you have to just discard this one and get a new phone, right? So you're again spending $800. So what they came up with an idea was not to make a phone as an entire package, but as a module. So behind how the phone was, I can actually show you the phone. Again, I'm just getting off topic, but just to give you an idea. So the phone had the modules. Let me show it. Yeah, see, do you see this thing? This is how the phone looked like. So this is camera module, right? So this, for example, when you bought this phone, the latest trend or the highest that phone could afford was for 8 megapixel camera, and if in 6 months someone came up with an idea of 20 megapixel camera, then you don't have to buy an entire phone. All you have to do is just pluck out that thing and put in the new module. That's it, right? So this was the idea of Project Ara, but then I don't know, for some reason they canceled it. Anyway, so this is how an actual Java program looks like, right? When you're done with your application, it doesn't look like an entire, solid phone or a solid application for that matter. It looks like this module. So whenever you think your application is going out of date or you want to update it with some, in some way, then all you have to do is pick particular module, pick it out, and replace it with a new one, right? So you can customize it in your way. That is what this luxury. Oops actually gives you this kind of luxury, whereas it is kind of possible in C, in a procedural language, but it would not be as easy as this one, what I would want to say. Are you clear with that modularity thing? Again, reusability, the same thing. Extendability, you can always extend your project. I'll tell you how you can extend the project, but anyways. So these are actually the basic core building blocks of what Java is: a class, object, and all these 4 object-oriented concepts. Okay, abstraction, encapsulation, inheritance, polymorphism. Again, I have a specific order of going about these things, so don't worry about that. Eventually, I'll cover all the 6 things. But yeah, I have a specific order. I'll tell you what an object is, and then you'll understand what a class is, and then I'll tell you what encapsulation is, and then we'll see inheritance, polymorphism, and in the last with the abstraction, which is really, really interesting. Okay. So first of all, let me just tell you what an object is. Forget what a class is. Once you understand what an object is, you'll actually you can infer what a class is. Anyway, so what exactly is an object? Forget Java. What do you call an object in real life? Is this phone an object? Is this laptop an object? Right? So an object is nothing but everything we see around in this room is an object. We ourselves are an object, right? So now there's a particular feature about an object. Okay, it has 2 things. If you say something is an object, then it has 2 features. Okay, if you say something is an object, then it should definitely have 2 features, and it should actually have to you should be able to list out those 2 features of any object. Okay, what are those 2 features? State and behavior. Exactly. What is a state and what is a behavior? State is something that an object has. Okay, what kind of state the object is in, and what is a behavior? What kind of operations or what kind of performance that object does? Those kind of things is nothing but a behavior. For example, let me just give you an example of bike. For example, I'm telling that bike is an object. Then how would you prove it? How would you prove it that bike is an object? You have what's the thing that I said? If anything is an object, then it should have 2 features. Something is state and something is behavior. Does a bike have state? For example, the bike definitely has. What is a state? State is nothing but a list of variables, like its speed, right? Shape, size, weight, and all those kind of static things. These are nothing but state. What is a behavior? What all things can a bike do, right? Exactly. So what all things a bike can do? Just list it out. It can speed up, slow down, all those kind of performance that, all those kind of operations that a bike can do come under behaviors. Okay, so whenever I say something is object, you should be able to clearly write two features, that is state and a behavior. Okay, say an example of the bike or whatever it is for that matter. So now, what is a class? So for example, let me just talk this. I've said for example, we humans are objects as well, right? I'm an object, you an object, but we are object C. This is this one feature of all the objects. For example, if I'm saying I'm an object and we all are objects in this class, then obviously we are sharing some similar characteristics, right? We have hair, two eyes, nose, some senses and all those things. We have similar objects, so we have similar features. So we can say, I can actually safely say that we objects are an instance of something generic thing called as human, right? Can you see that? So that generic thing is nothing but your class. So what I would say is there's a class called human, okay, and then it has all the states and all the variables, all the behaviors. What would be the states of a human?
Color.
Exactly, color, height, age, all the number things, all the static things can be listed under states. And what is the behavior? Behavior is nothing but the methods. Like, what do you think? Walking, one can method, and all the, whatever we can do, speak, talking, and all those functions, whatever you can list, they all come under behavior. So the reason I'm saying we are objects of class human, because we all have these things, right? We all have these things in common. You can work, I can work. We all have these things. But the only difference is your style of walking may be different than my style of walking. Your age might be different from my age. Your color might be different from my color. But that doesn't change the variable itself. It's not like I can walk, you can fly. No, you can walk, I can walk too. But there's a specific difference, but we all eventually do the same thing. So then I can safely say that we are an object of a generic thing called as human. So that generic thing is nothing but class, and the specific things that you keep on creating is nothing but objects. So just to give you an example, see, if I say that class is a dog is a class, then what would be the objects of dog, of the class dog look like? These four are objects of a class called dog, right? See, for example, a class dog would be something like just 4 legs, right? A tail would be a state. And what would be the behavior? Barking, fetching something, wagging its tail, and those things can be behavior. So all these 4 dogs have the same state, do the same kind of behavior, right? But the thing is, the values differ, and the way it does those operations differ. See, for example, color. Take the state of color. Okay. See, all the 4 dogs have different colors, right? Example, behavior. Word, wagging its tail. All the 4 dogs have a different style of wagging it. Some do it more frequently, some doesn't do it at all, or some has a definite pattern, or things like that. So if you get the idea of what a class and an object is, objects are instances of class. That is the formal definition that you'll find in your tutorials or any textbook or wherever. An object is nothing but an instance of a class, and class is nothing but a blueprint. Right? So if I can give you a class, you should be able to make objects of it. Just like, what do you think this building is? Is this a class or an object? No. This is an object, right? Because this is actually into existence. What would be a class? Blueprint or the building itself? See, I'll give you 2 things, the building and the blueprint of the building. Which one do you think is an object? Which one do you think is a class? Exactly. Blueprint is the class and the object. Exactly. So why would I say that? Because in blueprint, there's nothing in existence. I'm just saying that this thing, will have these many features and these many things. If I just change one thing out of it, if I just break the wall and make those 2 rooms 1 room, then it will be a new object, right? Because that building will not be same as this building, right? What is the difference? The new building will have 1 room less than this building. So even a minor change will result in a different object. Suppose take this thing. This is an object. If I reduce the size of this thing, it's gonna be a different object, right? A puppy or something, but it's not the same thing. So again, you can just come up with many such examples what a class and an object is. All you have to remember is a class is a blueprint of your solution, and then once you come up with a blueprint, you create objects of that thing. Okay. So again, any question about this thing, what a class and object is? Even if you have questions, you should have questions because it's all theoretical. Once we write a simple program about how a class and object work, you'll clearly understand what those things are. And if you don't, please ask me. I can go over this again and again all over night because I really like it. So yeah, let's write. Actually, let me show you one more thing, which is actually a good idea for a class and object. Application form point. So what is this? Now, see, this thing is a class or an object? It's a class. Awesome. It's a class, right? Because it just has some variable system. Is there any specific in this thing? No. So now what I'll do is I'll take this. This is a blueprint of how a form should look like, right? So what I'll do is I'll take this form, make 20 or 30 copies of it, and give each one of you one copy of this form. And I'll ask you to fill out your specific details. Now, once you give me back those 40 forms, are those 40 forms classes or objects? Objects, right? Because those are specific forms, right? Those reflect your information. But whereas the original form that I had, without filling any details, that is still a class, right? You get the idea? So now let's do one thing. Let's write a simple class. You know, not all the details, but some of details, at least name, age, or address, or something like that. Will state and behavior as well. This form as of now doesn't have a behavior, but let's add some kind of behavior and then let's create different objects. Okay, let's try and do that. Let me just create a new file. So let's create a class job application, right? Create a job application. Now it should have two things. What are those two things? State and behavior, right? So under state, let's add some variables. What? Let's add int age, and then it's what salary. Let's not take name strings because some of you might not be familiar with what a string is. So let me just stick with two int variables because all of you know what an int is, right? So yeah, this class job application has two variables, age and salary, and then let's add some behavior to this class. What do you think? What behavior can we have? Just will write a name. Just will have a method that will display age and salary when we ask for it. Okay, so let's just write a method display. Okay. So age right. So these two are states as in variables, and this is a behavior of the class job application. So when asked for, it can, the form itself can display what the age and the salary were. Okay. So let me just, do you understand this class? State and behavior, right? So now let's do one thing. Let's create objects of this class, right? Let's create object. How do you create an object of a class? There is a specific syntax or specific way of doing it. I'll tell you. First, write the class name because you want to tell the compiler which class's object you are making, right? So you're making the objects of class job application. So let's just write the name of that class, job application, and then any variable name, anything. You can give anything. Let's just write form1. Okay, so this is our first photocopy, just imagine it that way. So first form1 is equal to, you're making a new object, right? So you say new and then just repeat the class name. Now, doesn't it look like a method call, right? It looks like a method call, right? This is actually a method. This is called a constructor. I'll tell you what a constructor is in a minute. But this is the way you write any class. You create any object. So when I say that you have to instantiate a class, or when I say that you have to create an object of the class, this is what I'm talking about. This line number 19 is what I'm talking about. This is how you instantiate a class, or you create an object of a class. Okay. So now using form1, I can access these things. Let me just show you. I can say form1 dot age equal to 28. Form1 dot salary equal to what? 100K. It's fine. So now let's try and print the values. Out. We have a display method for that. So anyways, what we have to do is, instead of writing one more printout statement, all you can do is just call this display method. Okay. Can you directly call the display method? No. Just like you have, in order to access these two variables, you are using the object. In order to access the display method also, you have to use the object. Okay. So you have to do form1 dot display. Right? So now let's try and see what happens. The age 28 and salary 100K were printed, right? So why do this is called as dot operator. Okay, you see this dot. This is actually an operator. It has a meaning. This is called as dot operator. The dot operator is used to access state and behavior of a class. Okay, so this is a class. This is a blueprint, and you have created an object of this class, right? So you cannot write age and salary, because age and salary as of now do not exist if you do not use the object name. Once you instantiate, once the compiler has executed line number 19, a copy of this thing actually came into existence. That means that a copy of it actually came into memory in your system. Okay. So now, if it's not clear, let me tell you how it works. See, this is your class. This is your class, right? So assume this is how memory looks like. Okay, assume this is all the memory stored. So now what happens is, this is a class job application. So okay, so this is your class, right? So what I'm trying to say is, we have executed this program. So let me show you how once the program is executed, what exactly happens in the memory. Let me just give you a sneak peek of behind the scenes thing. Okay. So what happens is, once I run the program, the JVM or the runtime system enters into the main, because we know that main is the entry point for any Java program as of now. So it enters into the main program, and then the first line to execute is what? Line number 19. So it says, okay, I have to create a form1 object of a class called job application. So here is the job application class. And then what? After seeing this new job application, what it will do is, it will create a memory instance of this. That means it will take one memory slot, and then it will write variables, age, salary, and then also a method. Okay, something like that. So what it will do is, it should have some location, right? It should have some memory location. So let me just name that location as 2000. Okay. So now what this thing will do is, it will write age, salary, and all those things in a particular memory location, and it will take that address and make form1 point to this address. So now it will somewhere in another space, it will write that form1 is nothing but 2000. It understands. So in the next line, when you're using form1 dot age equal to 28, it first goes and checks what form1 is. So it goes and comes, okay, form1 is here. So what form1 is saying, form1 is pointing to the address 2000. So now JVM goes, okay, from form1, I have form1 is saying me to go to the 2000 location in the memory. So it goes to 2000 memory location. It sees all these things. So now which one should it select? Because you've provided, you've set form1 dot age and then assign 28 to that. So now it will take this age and it will say, hey, your age is 28. That's what it does. And for the next line, it says form1 dot salary equal to 100K. It does the same thing. It goes to form1. It sees that, okay, form1 is pointing me to 2000 memory location. So again, it goes to this memory location and then it sets salary is equal to 100K. And when you're calling form1 dot display, it does the same thing. Go to form1, go to 2000 address, you have a display method. So you just call display method and then the control from this line number 22 will go to line number 9 and then the age and salary are being printed. That is how it actually works. Any questions about this? So let's, yeah.
Where do we get this the location like this and all this? We automatically call
This address,
yeah.
Those are memory related things. We don't have to bother about that thing. All we have to know is when you store something, it goes and save into some specific memory. To explain you, I've taken some random memory location, but as a software engineer, we don't have to be concerned about these memory addresses. So that's not of concern. But all you want to know is when you're saying form1 will store some address, that is the address of the object. So when you're saying form1.h, that is how the compiler, the runtime system actually understands what do you mean by form1.h, right? Because form1 is showing that you have to go to this particular address. So when it goes to this particular address, the runtime system will see all these things, and then it will pick age, salary, and all those as you have specified here, form1.age, form1.salary. That is how it works. So let's try and create one more object. How do I create one more object? Same thing, no difference. All I have to do is just copy this thing, paste it here, and then just change the variable name, because there cannot be two objects at the same time. It's just stupid. So change form2, and then just let's change it to 38 and then 200. Fine, that is it. Now let's see how this thing goes. Oh, I'm sorry, form2. Form2, right? Now this looks fine. Yeah, let's just run this program. Yeah, it worked, right? So this is how you just keep on doing. Now the thing I want you to notice is, for example, this just has two objects. Consider I have 100 objects, and then do you see something strange or something that is being repeated in these two things? Do you see this? Right? Object creation, fine, because there's no other way, there's no other shortcut. When you want to create an object, you have to explicitly say that I want to create an object. But again, once you're creating an object, you have to keep initializing two values explicitly, like form1 age, form1 salary, form2 age, form2 salary. So there is actually this is actually called as repeating. The repeating is not something that is appreciated. There is a paradigm called as dry code. There is something called as dry code. This means do not repeat yourself. Okay, so you should always make sure that you do not repeat yourself while writing the program. If there is a smarter way of doing it, then go for it. But this is just redundancy. Again, I have to explicitly keep doing that, right? So what they came up with an idea is, you have, in order to in order to not do this, they have something called as constructors. Okay, so you can use a constructor to initialize values when you are actually declaring an object. In the line number 21 itself, when you are actually creating an object, right? When you're creating an object, then itself you can say that, this age and salary should be this. See, because the way it worked is, first thing was in the line number 21, what happened? Just went to some location, took that address and put it in form1, right? And later on, using form1, we assigned values. But what I'm trying to say is, instead of doing all that thing, when I'm assigning some memory, at that same time put the values. Don't use form1 again to go and assign the values. Can you do that? There is a way of doing that. You use something called as a constructor. So now I'll tell you what this is. This is also a constructor. This is also a constructor. This is called as default constructors. There are two types of constructor: default constructor and a parameterized constructor. Okay, again, you really have to remember this. These are really important. Constructors are really important. One thing is default constructors and the other one is parameterized constructor. Okay, so now what's the difference between default constructor and a parameterized constructor? I'll let you know. Yeah, I've said this is a default constructor, right? Because the thing is, let me just write this constructor here. Constructors are, again, the name might be weird, but what exactly constructor is, it is nothing but a method itself. It's just like these methods. Because I've told you, in a class, either there can be variables or there can be methods, right? Because a class only has a state and a behavior, nothing else. So when I'm saying that a class also has constructor, what I'm saying is constructor is also a method. So what I'll do is, I'll write a constructor. Again, the condition about the constructor is that the name of the constructor should be same as the name of the class. You cannot write, for example, when you can ask, sir, you said that this is a method and this is also a method. So when I can use any name in here, why not here? That's the whole idea. You have to make sure that the name of the constructor is same as the name of the class, because when you're declaring it, it knows what you're trying to do. When you're saying new job application, it directly goes and calls this thing. So is there anything in here? It's not. There is nothing in here. It's just empty, right? So that's the reason you can explicitly write values. For example, let's just do one more thing. Let's create another object, okay, and say form3, and then I don't want to explicitly assign something. All I'll do is form3.display. Okay, now what do you think will be the values of these two things? What are the default values of integers in Java? 0, 0, because I haven't assigned anything. So let me just do this thing. If I write age equal to 56, salary is equal to 300K, right? Now what do you think the values will be? Right. How this thing is coming up, age 56 salary. I never said form3.age, form3.salary. I never assigned, but even though those values are reflecting, what exactly is happening is, I'll tell you again for the line number 36 and 37, I'll tell you how this thing is working in here. What happens is, okay, sure, I got it. So what exactly happening is, again, when the runtime system, after done with form1, after done with form2, it came and trying to execute the line number 36. So what this thing is, job application form3 equal to new job application, right? So again, what it goes is, it will check up free memory space, and then it will create form3 thing here, and then see, once your runtime system is executing job application, even in the first two cases, it actually, what happens is, once it sees new job application, it goes to the class and checks. This is actually a constructor. This is nothing but a constructor, default constructor. So basically, you're calling a default constructor. So what happens is, it goes to the class and checks if there is a default constructor. Because in the first two cases when we executed, there was no constructor, there was no default constructor. Now I have written it, right? Earlier there was no this thing, there was no default constructor. So that's the reason whatever values I've assigned it, it showed up. And when I didn't write these things, what happened? The values here were 0, 0, right? So what happened was, it went, after seeing 35 line, it saw, okay, new job application. That means I have to create a new object of class job application. So this is a default constructor. So okay, now I should go to this class job application and I should see what's inside the default constructor. So it goes here and it sees, is there anything inside? Nothing. So that's the reason the values were 0, 0. But when you have written something, it assigns those numbers because you have actually assigned the values here. So in form3, what happens is, when the object was being created, it went to this default constructor here and it saw, okay, age equal to 56, salary equal to 300K. So because of that, even though when you didn't assign explicitly, those values were assigned by default. That's the whole point of you calling it as a default constructor, right? So now, what is the use case of default constructor? This is fine. What is the use case? For example, if I have forgot to initialize some variables, then instead of having some random values, I can always have my own specific, values, right? For example, in a banking application where you want to start a new account for every new, what do you mean by starting a new account? That means creating a new object, right? Every time someone opens an account, he's actually creating a new object as in your programming terms. So as a promotional offer, you want that with a new opened account, the variable my bank balance should be $500 as a promo offer. So instead of starting it from 0, if you don't assign anything, the variable my bank balance will be by default 0. But as a promotional offer, you want that for the first time if a person opens an account, by default, his bank balance should be $500. So you can just, if you want that kind of functionality, you have to put that in a default constructor, something as this form. If you have a variable my bank balance, what you'll do is you'll write my bank balance equal to 500. So no matter how many new accounts you create, even if you forgot to say that, you know what, you have to assign $500 to him initially, even if you forgot to do that, it happens by default, because the first thing that happens when you create an object is it goes and calls the default constructor, right? That is what it does. So this is one default constructor. Now, what if you want to specify? Now, for example, when I'm doing this thing, what are the values that are being printed? Okay. right? That is what it means. So there are two types. You know what are the two types? And now, are there any rules with this? There are certain rules that comes with these things. First rule, as I've told you, a constructor's name should always be the same as the name of the class. Remember that. And the second thing is, a constructor cannot have a return type. A constructor cannot return anything because it always returns the current instance of the object. Let's not get into that, but anyways, you cannot have something, see for example, what is the return type? This thing. Why am I writing void here? Because I'm saying that display method is not returning anything. That's the same reason why I'm writing void in main, right? Because main method is not returning anything. It's just a couple of lines getting executed. That's it. Main method is not returning something after everything is done. That's it. That's the end of the execution. That's what I'm saying here. And the display method also, there is nothing to return. So I'm using void. So even constructor is also a method. Constructor is also just a special kind of method, but it's also a method. So you can question, why cannot a constructor have a return type? That's the rule. A constructor cannot have a return type. Okay. Now, any questions about this parameterized constructor and default constructors? Okay, yeah, I haven't done that. Let's see what the thing will be. Age 45 and 50K, that is what we assigned? Yeah. Oh, no, you actually have assignments regarding that. So I'll push that thing on you guys. So make sure you finish the assignment about that. For the constructor? No, I'll take it up from here because there are many things to talk about for this specific example. Yeah. So again, now one more thing about this thing is you have something called as the local variable. Yeah. So let's do one thing. I'll just get to this right quick. Any questions about that? What is a class? What is an object? What is a constructor, default constructor, parameterized constructor, and all those things? No, right? If you have any questions, ask me. So what is the default access specifier for constructor? It's public. It's always public. Okay. So now it gets interesting here. Just give me a minute. What are these variables? I don't see that slide. Anyways, yeah, let's do one thing. One more thing I want you guys to understand is how many types of variables Java has. For example, in a program, we have 3 types of variables. First one is local variables, okay, and then you have instance variables, and then you have static variables. Reference variables are related to objects. That's fine. So you have 3 types of variables: local variables, instance variables, and static variables. Okay, and because you have to really understand the difference between these 3. Okay, so let me just make this clear. What variable is this? Age is a variable, right? You all agree that it is a variable. Okay, that's fine. Okay, so this can be one among 3 types, right? It can be either local, instance, or static. Is this a local variable? No, this is an instance variable. Instance, the way you say it's an instance variable is because this variable stays with each instance. Each instance has its, what is an instance? Nothing but an object, right? So every object has its own copy of age. Don't you agree? Let's just see this memory thing. See, this object form 1 has its own age, and then form 2 has its own age, right? Don't you agree? And then form 3 has its own age, right? So no matter how many objects you create, these 2 things will be copied in each object. So these 2, because these 2 variables are related with each instance, because every instance has its own copy of age and salary, those are called instance variable. The reason is, see, suppose if I use form 1 and I change age to 29, when I print form 2.age, will that matter for form 2? No, right? Because I've changed the variable age with respect to form 1. Form 2 will live its own world. It doesn't have to care what form 1 is doing. So that's the reason it has. So that's the reason it's called instance variable, because its scope is limited to its object itself. Okay, so this is an instance variable. Now, for example, what is a local variable? For example, let me just say here int x. I'm also trying to print x equal to what, 35, and then I can print x. Okay, fine. Because there is an integer x35 when I'm writing system print ln x, it knows what x is 35. But when I try to access x here, for example here, x equal to, see, I see an error. Why is that happening? Because only display method knows that there exists a variable x in the entire program. No other thing knows. Why? Because it was defined in the scope. Okay, it was defined inside the method. Okay, so only this method display knows that there is a variable called x that actually exists. Okay, so the scope of this variable is just limited to this method. So that is why it's called as local variable. So you can just use it locally. You cannot use it among different methods. But whereas these variables, it relates to each object. Every object has its own copy. So these are instance variables. You understand the difference between those two, right? So one way of defining them is, if you just want to remember it, you can say that instance variable is a variable that is inside of a class and outside of methods. Okay, that is one way of remembering it. Instance variable is inside of a class and outside of a method. But whereas a local variable is inside of a class and inside of a method. Right? So that is the difference. Now, the last but not least, I say that because it's really important. The third variable is a static variable. It's kind of interesting what static variable does. How do you declare? Again, static variables are also the variables that are inside class, outside of methods. But how do you differentiate between instance variable and static variables? Thing is, you just write static and in static, right? Yeah. In static x. Is it static and? Sorry. Yeah, static end. Right? So now, when I say, how do I see again, both instance variable and static variables are written inside class, outside of methods, but the static variable has a keyword called as static. Now, what's the use of having a static variable? It actually has an interesting use. Let me tell you. For example, see, we are making a class for job application, right? Now, this job application should be of some company, right? For example, Facebook, Google, can be of any company. The job application program that we are writing, it should be for some company. So let's assume, let's actually have a state that mentions the name of the company. So let's just write and company name. Right, so all these guys who are filling form 1, form 2, form 3 are by default applying for only one company because this job application belongs to this company. For example, let's just cannot have an end here, so let's just write string. Okay, so let's make it Google. Fine. So all these objects that we are creating, all these objects, all these different forms that we are writing are specifically for the company Google. Okay, so now for each object that we create, form 1, form 2, form 3, now there are 3 variables being assigned in each object, right? What are those 3? Age, salary, and Google. So now with age, salary, you also have another variable called company name. So even this object will have its own company name, this object will have its own company name. So do you see a thing? Do you notice something here? The thing is, even though age, salaries might differ for all the applicants, but one thing is common. All the applicants are actually applying for just one company, right? Because that company owns this form, which is nothing but Google. So what's the point of having each object its own company name? You're just wasting 4 bytes of memory with each object. So if you have 1,000 objects, wasting 4,000 bytes of memory, which is really expensive. So wouldn't it have been a good idea if you would have just taken this company name out and then just put it somewhere else so that all these objects would have shared this variable. Because see, if company name changes for one thing, then everyone should change, right? Because if the forms are not for Apple, if they're not for Google, if they're for Apple, then everyone is filling out forms for Apple, right? That is how it works. So instead of each object having its own company name variable, it would have been a good idea if that variable would have been shared by all the objects. How do you do that? How do you make all the objects share a particular value at once? If you change that, every object should reflect that change. The way you do it is by declaring those kind of variables as static. Okay? You write static in front of them, and all of a sudden this is no more an instance variable. Right? Until this point, before static, it is an instance variable. But once you write static, you are telling the compiler or the JVM that, hey, when you come across line number 8 and you see static, it doesn't mean that it is an instance variable. So don't give each object a copy of it. Just make a common thing and just share that copy with all the objects. So where does that static string company name stay? It stays with the class itself. It stays with the class itself. You don't have to put it in the each object. So when you write, so now the question is, you understood what a static variable does is, right? So now the question is, when you want to access company name, how do you access it? Whether you access it using form1.company name or form2.company name, or how? The way you use it through the class name, because it's associated with the class, right? There can be only one class, and this company name is associated with this class. So you just use the class name instead of form1.company name. You write something called as class name dot variable, which is nothing but Java application dot company name. Let's try and do that. We have a static variable here called company name, and if you want to assign something here, what you do is you write job application dot company name, and then you write Google or something. So even if you try printing it through, see, you have no Java application dot company name equal to Google, right? So now what I'm trying to do is, in the display method, I'll also add company name. So instead of this, what I'll do is name, and then I'll write, what is the variable company name? Right? Let's try and do that. Key company name Google. So now what I'm trying, so even if you change using any other form, you can also do form2.company name. You can, using object2, you can also change the static variable. Okay, so for example, if you have changed the company name using form2 and set it as Apple, if you're trying to print it through form3, will the change reflect or it won't? It will reflect the change. Even if you're printing it through form3, the name will be changed. It will be Apple or something. So that's the whole point, right? So as these instance variables, unlike these instance variables, static variable does not stay with the object, they stay with the class. Okay, so even if one object goes and changes this company name, all the other objects will see the change. Okay, that's the whole point. Do you understand the static variables? Any? About what? In the here, you can just specify it anywhere. It doesn't matter. There's no specific thing for that. You can, because this is a class, you can specify here or after the display method. That shouldn't be a problem. You can specify it anywhere. No. The only purpose, again, people do a lot of kind of coding in the constructor, which is absolutely wrong. The specific purpose of constructor is to initialize the variables. That's it. You cannot, even if you can do, don't try and do that. There's no point of doing that because constructor has a specific purpose. It was designed for a specific purpose. So let's just use it for that. It was designed to initialize the state. That means initialize the variables.
Can you do that modification and complete
Yeah, because I have initialized Google.
If you're writing void, you no need to call again, right?
If you're writing it here,
in display, no need to write again in form one or some company name or application or company name, no need to write.
exactly. If you're not writing company name here,
I have to call down.
yep. If you're not writing company name here, then you have to do here something like exactly. It says out and then print something and say job application dot company name, and then you have to initialize the company name. That is how it works. Either you can do this or just put it in the display method. That's up to you. Any other questions? Yep.
So if we in a form, if we change the company name, already in form 1 it's printed Google, right? So it will just change the in form 2 and 3, right? It will not change the form 1 as it's already.
Excellent question. What do you think? See, if I can repeat the question, what is she saying is, I have already set the value of company name as Google. So for the form 1 display, Google will be printed. And what is she saying is, if I change the value of company name using form 2, to some company is Microsoft. Okay, so then form 2 will reflect that change because obviously I've used the object. When I'm trying to print form 3, will that change reflect or not is what your question is, right?
Yeah,
I'm sorry.
Obviously it will change in a form 1, but what about the first one? It's already printed.
No,
it will not change that.
No, yeah, it won't change the first one. That's gone. It's done. I thought you were asking about the form 3 display method. If the form 3. Obviously form 3 will reflect the change, yeah. Form 3 will reflect, but yeah, form 1 it's gone. Once it's printed, it's out of the memory. Okay, any other questions about this? No? Cool. So now, the thing is, let's start with the first. Now you understand what a class and an object and what a constructor and all those things are, right? So let's start with the first object-oriented concept, which is relatively easy than all the other three, which is nothing but the encapsulation. Okay. Again, I won't tell you the encapsulation definition right away because again, there's just no point. You can always read that in textbooks. I'll actually make you realize what encapsulation is. Okay, let's just do it through a simple example. Now, the problem with this class, again guys, if I'm speaking too fast or too slow or unclear, let me know. I have this weird habit of, just getting away so quick. Anyway, yeah. So the problem with this program is these integers are public. I mean, they're not literally public, they're default specifier, but what I mean to say is any other programmer or any other class can actually change the values of these three variables. Okay. I mean, what I'm trying to say is if I have another class here, if I have another class, something as, Y class or something like that. So that Y class can act, there's actually a way of changing these variables through other class objects. That's possible because these variables are not private. Okay. So it is not a good idea to do that. It's not a good idea to do that. So the best programming practice or the official Oracle documentation, what they say is to always hide your state. Okay, never let the object state reveal to the external world. Never do that. Always hide the state. And then if you are hiding the state, what I mean by hiding the state, making these things up as private. Okay, what happens when I make these things as private? Only this class can have access. Only this class's members can have access to this thing. Okay, other classes members cannot have access to that. So now, when I'm saying hiding the state, then if some other class of objects want to change, how would they change that? See, it might not be clear. Let me just show this image. Okay, this is actually a screenshot. You know what this is? I mean, this is a kind of machine language, not exactly, but yeah, this is binary or hexacode. You know what this is? This is actually a program. This is a program which computers actually understand. What program is this? Just a void guess. Exactly. This is the program for hello world. We wrote all the simple programs, right? Printouts, this is what happens, to once we compile and do all the stuff. This is how it looks. Not exactly, but even for a computer, it won't even understand what 6 EF. All it understands is zeros and ones. So when you type a program and feed it to the computer, it's all a bunch of zeros and ones. Again, so yeah, this is the thing I wanted you guys to show. So this is how a real software object looks like. Okay. So you have inside, you have this state. There is nothing but your variables or fields, and then you have methods. It's just not a random way of putting it. There's actually a meaning for that, for this figure. See, do you see this? Fields are actually surrounded by methods. So that means if you want to insert into this, real object, you cannot just directly go and access these. You cannot just directly pull out these things. You have to go through this shield, through the method. So this is verbally translates to that a state of an object should be hidden from the external object or the external world. If they are hidden, then how should someone communicate or talk to this state? If someone else wants to change the state, how do they do that? Through the methods, through the method. So I'll show you one way of doing that. Okay, so let's do one thing. For example, see what's happening here is, see, this is one class job application, right? This is a class job application, and this is a class object type. So these are two different classes. So as of now, age, salary are accessible in the different class also, right? Because see, I'm able to change the variables here, age, salary here. This is another class, this is another class. This is not a good idea. Variables of one class should be able to be changed by only members of that specific class. Okay, it should not be able to change by the next class, right? Do you understand that class object X is actually changing the variables of class job application, that is age and salary. So you should not do that. So in order not to do this, or not a user to to do this kind of thing, what you do is you make those variables private. So once you make those two variables private, that means only class members of this particular class can change these two values. So when I say class members, what does it mean? Again, class members means two things. Class members means data and methods. That's it. Okay. So these variables and all these methods combined together called as class members. Okay, because see, these are all belong to one class. So there are like roommates kind of thing. They are class members. Okay. So once you declare a variable as private, then only the class members can access those private variables. So now, earlier in the object X, we were directly accessing age and salary, right? So let's see what happens now. You see error here. Why did that happen? Because class object X doesn't have a permission to change private variables of some other class. It doesn't have that access privilege, right? So now how do we do that? I mean, this was a fine use case. I mean, sometimes that's fine. You have achieved that security. Now you have made your variables private. Fine. This class is fine. I mean, what I mean is, age and salary cannot be changed with from some other external class. But if you require that, you want to change variables, and which is often a requirement, you always keep changing the variables. But obviously, right, a state never stays the same. If I'm sitting now, I'll walk, I'll stand, I'll have many states, right? So what if I want to change the variables? How would I do that? You can also write protected, but that is not related to this thing. It actually has an entire different thing. What you do is, there is an actually elegant solution for this, guys. What you do is you write. See what I've told you. Once the variables are private, you can use the public class member. You can use the class members to change these things, right? So what I'll do is I'll write two methods. I'll write two public methods calling as set age, public void set age, and then I'll say and a, and then I'll say age equal to a, and then I also write public void set salary int s, and then I'll write salary equal to s, right? So now what I can do is, instead of directly accessing the variables, because those age and salary are now private, I cannot directly access those variables. But instead, what I can do is I can always use the public methods, right? So what I'll do is I'll use this public method to change these values. So see how it's done. This is a public method, right? So what I'll do is instead of directly writing it, I'll say form1 dot set age 28, and the same thing here. Set salary 100K. Isn't the problem solved now? Right? Same thing for these two things. So just remove this form 3. Yeah, that's fine, right? So now, can we not use constructors only? Again, you can obviously use constructors, but the problem with the constructor is you as a developer have to provide the values, because you are writing code, fine, you'll insert the values in the constructor. But what if you want the user to push the values? Because obviously age and salary are not set by me, right? Those are set by the user. So in that case, what you'll do is you'll take the values from the user, and again he'll pass it through set age or those cases. One of the guys who is training online asked me. So anyways, so now one thing is solved, one problem is solved. Even though the variables are private, I can use the public methods to access those private variables. Now, I'll write this line says out and age form1 dot age. Okay. If the variables weren't private, this would have been possible, right? I could have directly accessed those variables form1, because I want to access the variables of form1 age again, right? Because the variables are private, I cannot do that. So now how would I want to get the values of age? I don't want to, initialize something or set something. I just want to print those values. How would I do that? Again,